Hi everyone, today I'll be talking about 2004 MC12B Problem 24. In triangle ABC, AB equals BC and BD is an altitude. Point E is on the extension of AC such that BE equals 10. The values of tan CBE, tan DBE, and tan ABE form a geometric progression, and the values of cotangent DBE, cotangent CBE, and cotangent DBC form an arithmetic progression. What is the area of triangle ABC? So from this first piece of information about the geometric progression, we know that tan dBE tan squared dBE is equal to tan CBE times tan ABE. And let's let dBC equal to alpha, and we will proceed by substituting the angles in. So tan squared dBE equals tan dBE minus alpha times tan dBE plus alpha, because we see that CBE is and ABE. Since this angle is also equal to alpha. So we have this, and from the right side we can use the tan trigonometry formula to write it as, and I think it's called the Salmon difference of angles formula. Anyways, so this is tan dBE minus tan alpha over 1 plus tan dBE times tan alpha. And then the second one would be tan dBE plus tan alpha over 1 minus tan dB tan alpha. And we can multiply these out, and it will result in difference of squares. So we'll get that tan squared dBE minus tan squared alpha over 1 minus tan squared dBE tan squared alpha. And this is all equal to tan squared dBE. So when we multiply this out and rearrange it, we'll get that tan to the power 4 of dBE minus 1 times tan squared of A is equal to 0. And obviously tan squared of A is not equal to 0 because A is non-negative. So we must have tan 4 of dBE minus 1 equals 0. So this tan 4 of dBE equals 1. And solving this, we will get that tan dBE equals 1. So dBE equals 45 degrees. Now we use the second piece of information about the arithmetic progression, and that will tell us that 2 times cosine cotangent CBE is equal to the sums of dBE and dBC. It's the sum of cotangent dBE and dBC. Yeah. And if we substitute this so it's in terms of A, we get 2 cotangent 45 degrees minus alpha equals 1 plus cotangent alpha. And since dB is obviously 45 degrees, so we can use the cotangent difference of angles formula to get that this is equal to 2 times cotangent alpha plus 1 over cotangent alpha minus 1 is equal to 1 plus cotangent alpha. And multiplying this out, we'll get that cotangent alpha minus 3 times cotangent alpha minus 1 equal to 0. Obviously, cotangent alpha can't be equal to plus 1. Obviously, cotangent alpha can't be equal to -1 because alpha is less than 90 degrees. So cotangent alpha must be equal to 3. Now we can use the fact that DBE equals 45 degrees. And we know that the cosine of 45 degrees is equal to root 2 over 2. And it's also equal to adjacent over hypotenuse, which is BD over BE. And it's given that BE is 10. So we can solve that BD is equal to 5 root 2. Okay, now we can use the fact that cotangent of alpha equals 3 because cotangent of alpha equals 3, and it's also equal to adjacent over opposite, which is equal to BD over DC, which allows us to find AC. So AC is equal to 2 times BD over 3, which is equal to 10 root 2 over 3. So then the area is 1 half ACBD, which is 1 half times 10 root 2, over 3 here, over 3 times 5 root 2, which is equal to 50 over 3, which gives us the answer choice of B. Thank you.